So what we could obtain is summarized here. So we obtain the transformation matrix of D of E, D of C2, and D of sigma V, and D of sigma V prime. And these combination of transformation matrix is called as gamma 3. And because we use 3 basic molecular orbital and to the basic set of the PS, PA, PV combinations, right? And there's several things you have to know. Is one of them is the summation of the diagonal elements is called as an index, right? So, for example, in the case of DE, so you have to sum up the 1 plus 1 plus 1. And in the case of C2 case, minus 1 plus 0 plus 0. And this one's minus 1 plus minus 1 plus minus 3. And this one is 1, something like this. These are called index. And this value is kind of important value, and coming back here later on. But just remember that in the transformation matrix, and some of the diagonal elements is called index. Okay, and also now we are moving on to further analysis of this transformation. Okay, and actually at this moment, please be patient to try to understand what I'm doing. But the reason why I'm doing is getting more clear after a while. So please be patient to and try to understand what is going on. So looking at the transformation matrix, this 3. So it's actually this 1 is always 1. So only this region and this region are separated somehow, because these are region always 0, meaning that it's more clear that the PS is always expressed by PS, right? PS is changed to PS or minus PS. And then PA and the PV are sometimes exchanged. So these two matrices, the 2 by 2 matrix is kind of interacting each other. So what we could understood is this part called X and this part called Y, kind of the independent. So the PS is always X region only affect PS orbital, and Y region only affect the PA-PV combination. So these could be separated. And now the X is redefined as gamma 1, because we just pick up the number of the change of PS orbital, right? This value. The sigma V operation is 1 PS, and then E operation 1, sheet operation minus 1, sigma V dash operation minus 1, right? So 1 minus 1, 1 minus 1. And also Y is defined as gamma 2, so which is the transformation matrix applied for PA-PV combination. And these matrices are 1, 0, 0, 1, 0, minus 1, 1, minus 0, or something like that. So you have 4 2 by 2 matrices. And this kind of operation, so separation of the independent components, is called reduce. Okay? And we have to reduce as much as possible as we can to simplify the symmetrical operation. And if once it is no more reducible, it is called irreducible. Okay. And in the next step, actually, there's another step to reduce this matrix, and which is now the orbital made of the PA and PB is somehow converted into the sum of them and subtraction of them. And don't ask me why, and you will understand after calculation. So what it means, PA plus B and PB and PA minus PB is something like this. So this is PA plus PB. So by summing these two orbitals, you are going to think about the single molecular orbital. And then this one is PA minus PB. So this one is P1 equal, P2 equal. So by thinking about these kind of orbitals, and again, we are going to think about the transformation matrix. And obviously, by applying the P1, P2, and then applying E, doesn't change anything. So it means the transformation matrix is 1, 0, 0, 1. Right? When C2 operation is given, C2, in this case, just think about the rotation along the molecular axis and then 180-degree rotation. And the P1 is actually the sign is changed, right? So by rotation, it's a plus minus, right? But if this one rotated, P2 is rotated, it doesn't change, right? So meaning that this one is going to change into minus P1 and P2, meaning that minus 1, 0, 0, 1. And then in the case of sigma V operation, sigma V, similarly, the sigma B operation, it's in the P1 case, it doesn't change, but P2 case, its sign is flipped. So what happens here is P1, P2 is changed to P1 is same and minus P2, and this gives a 1, 0, 0, minus 1. And similarly, if you try the sigma B dash case, it's like P1, P2 is changed into, let me see, sigma B dash case, the both sign changed. So minus P1 minus P2 equal minus 1, 0, 0, minus 1. Right? So what you could notice here now is P1 is always expressed by the P1, and the P2 also expressed by P2. Because in the matrix, it's kind of separated like this. So now the P1 and the P2 are kind of independent. So these can be reduced. And for P1 case, d E equal 1, d of C2 equal minus 1, and then d of sigma B equal 1, d of sigma B dash equal minus 1. Then in the case of P1, P2 case, 1, C2 equal minus 2. Oh, no. this is 1, and the sigma b equal -1, and the sigma b dash -1, like this. So these molecule did the transformation are reduced to the one-dimensional for any cases. So it's of course it's kind of really trouble to do every time for each molecules, but don't worry, this is more easier categorization that's possible for just using some of the